Now let us learn how to inscribe regular polygons in a circle. In the sense, I may start with equilateral triangle, square, regular hexagon. Such polygons, they must be exactly fit, touching the circumference of the circle, and they should be within the circle. So how to construct this? And also this can help us understand a circle better and several other angle constructions using compass and ruler alone. So observe, I am drawing a circle using any comfortable radius. It's a random radius selected by me, and I have drawn the circle, complete circle. Now let me draw one of the radius. Now, at one end of the radius, which is on the circumference, with the same compass distance, I will cut one arc. So you can imagine one equilateral triangle here, because this is radius, this is radius, also this is radius. So indirectly we have created 60-degree angle, which is actually the method for 60-degree angle construction. I will continue along the circumference to get 120-degree angle. So you can visualize another equilateral triangle with radius as one of the side, another radius as another side, and equal length unit. Again I will repeat and continue the same process. So a semicircle now is trisected. You can observe, if I hold the ruler along this diameter, 1, 2 and 3. There are 3 equilateral triangles within this semicircle. So now I will continue the same to complete the another semicircle part also. It is trisected now. So now if I join these points, all the points should be each consecutive arcs drawn combined. What is obtained is a regular hexagon. Observe, it has 6 sides. 1, 2, 3, 4, 5, 6. So indirectly, if I join the diagonals, I will be getting 6 equilateral triangles within the circle. Now, in case alternate vertices are joined, what is obtained? Yes, we get equilateral triangle inscribed in a circle. If at all, if the bisection of each side of this hexagon is done, I continue the bisection process. Yes. Observe what is obtained. Okay, now how we can this is another hexagon which is outside the circle. Now also there is something to be noted here. Any chord which is bisected within the circle, if any chord is bisected, that bisector will pass through the center of the circle. So we are using this idea when we are constructing a perpendicular to a given line segment. Say a line segment is given and a point is given. Say here there is an external point P. And if we are supposed to draw a perpendicular to this line segment from the point external point P, then normally what do? We start from this point and we cut this given line segment So I will do it here. Say this is the line segment and there is a point P. We start from the point P and we cut this line segment. We have just learned to show only this part. We cut and draw one arc on the line segment given. So if you imagine, we are actually drawing the full circle. Observe, this has become the chord of the circle. We made it as chord of the circle, whereas the point becomes the center of the circle, and we are bisecting this in the next step. Observe, when we bisect, we take more than half of the chord and draw arcs. See, observe, even if it is drawn only to one side, it will pass through the center. So we don't normally draw here. We have learned that we use only this part. So any point is given and a line segment is given. We start from the point, we make that line segment as a chord of the circle, and then we bisect that chord to get the perpendicular. This is guaranteed that whatever we obtain is a perpendicular. Similarly, when the point is on the line segment, say a line segment given and there is a point x given on that time also we start from the same point and we are supposed to draw perpendicular to the same line. So we make this chord of the circle by drawing arc on the same line segment. Point is but on the line. Now the chord is diameter itself and the point is center of the circle itself. So if I bisect this diameter, what happens? The diameter is the chord now and we bisect that, we get the perpendicular. The perpendicular is obtained and that perpendicular will be making 90 degree at the point given. So it is a bisector. So in both the cases, the chord is the line segment given, point is the center. So here the chord is the diameter itself, the line segment given. When the point is on the line, when the point is off the line, both the perpendicular drawing relies on this method, that every circle's chord, if bisected, the bisector passes through the center.